All right, so we're going to start by classifying numbers. So the beginning, we have a lot of writing. And then once we get into it, then we'll do a lot of looking back at this sheet and comparing it to the previous one. Okay, so are numbers you can count on your fingers. Okay, so numbers you can count with your fingers. Okay, examples would be like 1, 20. You can even go up to 4,000. Okay, if you really wanted to, right? But then whole numbers. So after natural, our next classification is whole numbers. Whole numbers are natural plus 0. So natural plus 0 are whole numbers. So that's what we're going to write, natural numbers and 0. So the only difference is that we add 0 into whole numbers because I can't technically count that with my fingers, right? So examples would be 0, 20, 4,000, right? So those are the only difference. Now, do we all remember what negative numbers are? Negative numbers are numbers below 0, right? Below 0, such as negative 200, negative 1, okay? So after whole numbers comes integers, and integers are whole numbers plus negative numbers. So whole numbers and negatives. And negatives. So examples would be like negative 3, negative 1, 0, 1, 3. Okay, so they're whole and positive, or they're whole numbers and negative whole numbers. Okay, now we have to talk about fractions and decimals. Okay, we're not gonna talk about fractions a whole bunch real quick, but we are gonna talk about decimals. Terminating means ending. So numbers that stop, such as like 2.5 or negative 3.212. Numbers that stop. Okay. Repeating are numbers that go on and on forever. So like a common one you probably know is 1.333333, never ending. You'll probably see that written as 1.3 with a repeating bar over it. Okay. Other numbers or other examples could be like negative 3.212121 or 1.43212121 dot 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 dot. Okay, so sometimes repeating numbers might have different numbers in the beginning, but the rest of it is the same number over again. Okay, so fractions and decimals are all introduced in rational or irrational numbers. Okay, so certain decimals are rational and certain decimals are irrational. And we'll get more into that next unit. But fractions is important. All fractions. Fractional equals rational. Okay, so that's kind of how I try to remember it. All fractions, no matter what, are rational. And repeating and terminating decimals. So irrational numbers are no fractions, no whole numbers, none of that, but certain decimals, right? So if we have decimals that are repeating and terminating over here, our irrational are the opposite. Non-repeating and non-terminating decimals. And also non-perfect square roots. Right? And non-perfect square roots. And we'll talk about what those are in a moment, okay? So there's a really famous non-repeating, non-terminating decimal that you probably know. It's a food. It's pi. And it's irrational because it never ends and it never repeats. Another example could be 2.4567123 6 7 1 2 4 9. I don't know. Okay, dot dot dot. That dot 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 tells you that it never stops. Okay, and we see that none of the numbers repeat consistently, so it's non-repeating, non-terminating. Okay. A non-perfect square root is a square root that doesn't simplify to a whole number. So I'll show you how to do a square root on the calculator. So an example is like the square root of 5 or negative square root of 10. So numbers that when you divide them by themselves, like by the same number, it doesn't give us a whole number. Okay. So rational are fractional and repeating and terminating decimals. Irrational are non-repeating, non-terminating. Real numbers are all the numbers, right? But we funnel up rational and irrational. So rational and irrational. Okay, so let's get to some practice then. We want to list all the classifications of -1. Okay, so maybe come up here, negative. Where are negatives introduced? Negatives are introduced here, right? Well, here, which filter up to integers. So I'm going to say it's an integer. If it's an integer, that funnels up to rational, which funnels up to real. Okay, so it's rational and real. The square root of 5. Okay, we did that as an example, so that was helpful. That's a non-perfect square root. Non-perfect square roots are irrational, okay, which is also real. So irrational and real. I want you to pause and try the next two on your own, okay? It's like a funnel, right? So 0 gets introduced at whole numbers. So if it's whole, it's an integer. It's an integer, it's rational. It's rational, it's real. It just funnels up. Okay, so it's all those classifications. And then the last one's a decimal. Does it have those dot dot dots? No, so that means it's terminating. Do any of those numbers repeat? No, but it is terminating. So terminating is rational. And if it's rational, it's real. So example 2 is the same thing, except now you have check boxes, okay? So pause and try example 2 on your own. Okay, so the first one's fractions. Remember, fractional, rational, they rhyme, right? Fractional, rational. So it's rational, and if it's rational, it's real. Second one is a repeating decimal. Repeating decimals are rational. Repeat, rational, right? 2 R's. And if it's rational, it's real because all numbers are real. 9 is a number I can count on my fingers, so it's natural, which means it's whole, which means it's an integer and a rational and a real number. Okay. Example 3, we want to correct these if we need to. If a number is rational, then it's also an integer. So that one's kind of tricky. If it's rational, then it is also an integer. Well, are decimals integers? Are fractions integers? No, so this is false, right? If it was reversed, if a number is an integer, then it's rational. That would work, right? But not the other way around. If a number is irrational, then it's also real. What do we think? We're going with true, right? All numbers are rational. All right, I want you to pause and try C, D, E, and F. So make sure you correct them if you say false. All right, so hopefully for C, D, and E, you got true. The last two were false, right? 9.823 is not a number I can count on my fingers. It is a decimal that terminates, so it's rational. -1/6 is a fraction, fractional, rational, okay? All right, if this is confusing, don't worry, we'll do lots of practice, okay?